What is the definition of an earthquake? It is when two bodies of rock slide past each other or rupture. Energy is radiated out from the rupture in all directions. These are called seismic waves. Seismic waves travel and are detected at seismic stations and help locate and determine the size of the earthquake or its magnitude. We have had increased seismic activity in Oklahoma the last 3 years. On November 5, 2011, the largest earthquake ever recorded in Oklahoma struck near Prague, Oklahoma. It was a magnitude 5.7 on the Richter scale. The quake was reportedly felt as far away as Illinois, Kansas, Tennessee, and Texas. I felt it in Ada, Oklahoma. A number of earthquakes have been felt since, mostly in the 3 to 4 magnitude range on the Richter scale. This is a logarithmic scale, so a magnitude 5 earthquake is 100 times greater than a 3 magnitude earthquake. Recent repeated quakes have been occurring in south central Oklahoma and in the Edmond area. In 2013, a study was published in the journal Science, which linked earthquakes in Midwestern United States to underground injection of wastewater. It was postulated that a net fluid volume increase after years of injection lowered effective stress on reservoir-bounding faults. Decades-long lags between the commencement of fluid injection and the onset of induced earthquakes are thought possible. A more recent study, published in the journal Geophysical Research Letters, connects earthquakes in the Youngstown, Ohio area in 2010 and 2011 to wastewater injection in the North Star 1 injection well. Earthquake triggering can be caused by both natural and anthropogenic factors. Natural causes are dynamically by the passage of seismic waves, statically by local stress changes from previous earthquakes, also from natural fluid movement. The latter may be the cause of many aftershocks. Hydrologic loads also can cause earthquakes. Anthropogenic causes are mining and oil production from the subsurface, from fluid injection, and from geothermal production and thermal contraction. Seismic events occur with varying degrees of intensity. Many more are smaller rather than larger. The energy released may reach the Earth's surface and cause noticeable shaking. Earthquakes of magnitude less than 3 are generally not felt at the surface. Damage to structures, if any, depends on the amount of energy reaching the surface, the geomechanical characteristics of the soil, and the condition of the structures. The epicenter is the location of the surface above the slip event. The hypocenter is the event's actual location in the subsurface. Induced seismicity is a term that refers to seismic events linked with human activity. It's well understood to be either or both an increase in shear stress with accompanying mass changes and thermal changes, or increase in pore pressure. This can be from fluid injected under pressure, but also can be from fluid injected under little or no pressure, which can generate a hydraulic head, which can increase pore pressure. Induced seismicity from fluid injection has become a greater concern over the past few years, with a significant number of new possible cases. Induced seismicity can occur when faults are already near failure and pore pressure is increased. Fluids injected can originate from multiple types of activities, including produced waters from hydraulic fracturing and enhanced oil recovery from carbon dioxide injections. The National Academy of Sciences recently released a report on induced seismicity. The major findings of the report were that hydraulic fracturing does not pose a high risk. Wastewater disposal does pose some risk, but the frequency of known events is low. Carbon capture and storage may have potential for inducing seismic events, but much is unknown about it. The report further indicated that methodologies can be developed for quantitative probabilistic hazard assessments of induced seismicity risk, and that there is a need for federal agencies to coordinate on induced seismicity response actions. With respect to underground injection control wells and induced seismicity, there are more than 150,000 Class II injection wells in the U.S. Oklahoma has more than 10,000. Strong linkages have been posed for 5 events in the U.S. in the past few years. Some of these are still undergoing review. It is thought by some that extended injection can lead to seismic events. Very low seismic is common and does not pose any problem. A small subset of injection wells are sited at locations with unexpected geological features. On occasion, these can cause seismic activities that can be felt at the surface. In the U.S., 150,000 to 200,000 injection wells operate each day. Rarely do these wells cause noticeable seismic activity. This next table shows induced seismicity from injection in terms of both best documented cases to date and also some general observations. For instance, in 1976 in Rangeley, Colorado, this case was published in the journal Science. In Paradox Valley, Colorado, this was also published in the Bulletin of Seismology, Society of America. Another case was in Germany. Also another one in Basel, Switzerland. And then one at the Rocky Mountain Arsenal in Colorado in 1981. And again, published in the Journal of Geophysical Research. The general observations observed for these different cases are that earthquakes generally occur first near the well and migrate away from the well with time. Earthquakes have a clear temporal correlation to injection. Time and spatial distribution of earthquakes can generally be related to diffusion of pore pressure. Earthquakes can occur over long distances, some more than 20 kilometers. Modifying injection parameters can alter earthquake production. The underground injection control programs conducted by the states and by EPA are examining this issue of earthquakes and underground injection. They are going to be formulating new guidance on this topic in the very near future.